So, welcome, Kathy and Karen, who are updating us on progress of the Gene Fusion Oncogenicity Workgroup. Uh, Today, we're going to hear about the framework this group's been developing and kind of where we're at in the process of trialing it out. I'm looking forward to the discussion to follow at the end of the presentation, but don't want to take up too much time with the introductions or orientations. So I think I'll just hand it over to Kathy and Karen.
Thank you, Alex, and welcome everyone. Uh, so Kathy and I are going to be presenting on behalf of the entire Gene Fusion Oncogenicity Workgroup. I believe this is the third update that we're giving to the VICC. This is so some of these early slides may look familiar to some of you who I know have attended these calls previously. And this is just to remind everyone that this is an international work group of multiple members, and all of the original members shown in this slide are still in the work group. However, some of their institutions have changed, and some of us have more gray hair than when we first started. Anyway, next slide. So, the goal of this project is I'm competing with the overhead. So the goal of this project is to develop recommendations and procedures for the classification of gene fusion pathogenicity, which we'll refer to as oncogenicity, since this is occurring in cancer. And Kathy, if you could go to the next slide. So I'm sure everyone on this call is familiar with this previous publication on standards for the classification of pathogenicity of somatic variants in cancer. These standards specifically did not include classification of oncogenicity of gene fusions and also copy number variants, with the exception of very small deletions that involved single genes. Next slide. And this is a figure taken also from that previous publication that illustrates that variant classification and interpretation is a stepwise process. And the scope of the Gene Fusion Oncogenicity Workgroup involves this middle step here of oncogenicity classification. So this entails classifying gene fusions into one of five buckets of either oncogenic, likely oncogenic, fusion of uncertain significance, likely benign or benign, using criteria that we have been developing. And this is also to point out that what we are doing does not entail the next step of clinical significance, which involves the AMP-ASCO-CAP tiering. Next slide. And so this is the deliverables that our work group has promised. We have been working on a manuscript that not only describes the criteria that we've come up with for classifying gene fusion oncogenicity, but it also involves a list of databases and other resources that are useful for classifying gene fusions. And we've also acquired probably about 40 to 50 gene fusion examples that we've used to work through to develop and refine our classification criteria. And we also plan on including many of these in the manuscript itself, because I think the examples are particularly useful for showing how to apply the criteria and also some of the variability that can occur. We were also committed from the onset to doing community outreach, doing periodic updates to the VICC as we're doing today. We also have a call scheduled with the ClinGen Somatic Group, and that's going to happen on June 15th. And we also are getting input from other professional societies. So Valentina Nardi on our work group is our AMP representative. And we're also taking input from ClinGen and the Cancer Genomics Consortium as well. Next slide. And this just shows some other presentations that the work group has given to disseminate the work that we're doing. So I gave a speed talk at last year's Cancer Genomics Consortium annual meeting. Um, this was a talk that involved about 6 slides, and so it was just a very quick run through of what our group is doing. And there was also a session at AMP last fall on advances in oncogenic evaluation and nomenclature of gene fusions in solid tumors. And Akshamoy Roy, Jason Saliba, and myself each gave presentations in this session on different aspects of gene fusions, including the efforts of this work group. And then Gordon Arasa put together a proposal that was accepted for the upcoming Cancer Genomics Consortium in August. That involves this session in which Fadi Mikhail is going to give a talk on classification and interpretation of copy number variants in cancer. Marilyn Lee is going to give a presentation on small variant classification and interpretation. And then I'm also going to be giving a presentation on gene fusion oncogenicity. Next slide. So working through the example gene fusions, we spent a lot of time looking at different work group members' typical curation process that involved much of the same criteria between different people, including relationship to the type of neoplasm that a fusion is found in, different fusion elements, such as whether or not one or both partners are known to be involved in gene fusions, whether the gene is typically a 5' versus 3' partner, what functional domains are involved, the reading frame, and so forth. And as I already mentioned, we curated a number of resources and databases that different people use to accomplish this classification. And we developed a framework for applying relevant criteria to varying gene fusion categories. And I say varying because initially we had 4 different gene fusion categories. However, we found that it was somewhat difficult for people to sometimes even figure out which category they should be using for a given gene fusion example. And so we ended up collapsing those into just 2 different categories, which you'll see in a moment. And one of our goals was to align with the already published standards for classifying somatic variants as much as we could. And so this is another figure from that previous publication. And we are using a point-based system, and we have kept the same point scale that was used for classifying other somatic variants. Next slide. And so these are the 2 gene fusion categories that we've ended up with. Scenario 1 is when one or both partners, which we've termed genes A and B, have been previously described in a gene fusion. And previously, we had these separated out into 2 different categories, at least 2 different categories, maybe 3, that involved either just one gene having been described in a fusion or both. And for various reasons, it just was sometimes difficult to apply to a specific, just one specific category. So we ended up merging those into this single scenario. And then the second scenario is when neither gene A nor gene B has been previously described in gene fusions. And it's been very difficult for us to find examples for this scenario because by definition, if you're using some kind of targeted gene fusion detection panel, you won't have examples of these because you're only looking for known gene fusions, at least for one partner. And so we have a number of examples of fusions in which one gene partner is known to be involved in a fusion and the other one is novel, but we have had difficulty coming up with examples of this scenario too. Anyway, if you go to the next slide, this one shows the different criteria that we've come up with for scenario one and the points that are applied for different responses within the categories. So, and Wes Gore actually came up with this very useful worksheet that has drop-down menus for the different choices under each criteria with the points, and the worksheet auto calculates the total score. And so for the first criteria, genes have been previously described in a gene fusion. There are actually four different choices in this category, actually a fifth choice, which is just that if neither of them have been previously reported in a gene fusion, then you should be going to scenario two. But other than that, there are four different choices within this category or within this criteria. Another criteria is the orientation of the genes, of the gene partners within the fusion. And I should also mention that consistent with the previously published classification of somatic variants, in addition to these criteria in the worksheet, there's also another column that either further elaborates on the criteria and also describes caveats to each criteria. Another criteria is that exons at the junction have been previously described for one or both partners. The fusion consequence, which could either be gain or loss of function, is predicted to be consistent with that previously described for the fusion partner or partners. And that also takes into account retention or loss of key functional elements in one or both of the genes in the fusion. Of course, there's also criteria that take into account the reading frame status, whether it's in or out of frame, and whether that matches at least one of the known fusion gene partners. And then there's additional criteria on the next slide for this scenario, which include whether or not the fusion or at least one of the partners has been previously described within the neoplasm that it's found in. Also, there's a criteria to try to exclude events that could be read-through as opposed to real gene fusions. And then also if there's a novel partner, whether or not that partner has a similarity in biologic function to a previously described fusion partner. And then the next slide describes the criteria for scenario two, and there's quite a bit of overlap with scenario one, but there are some differences as well. So one of the criteria is whether or not genes have a known or documented cancer-associated function, either as an oncogene or tumor suppressor. Again, it takes into account reading frame. Um, if the one or both genes has a known cancer associated function. Again, it takes into account the possibility of read through and also whether or not variants associated with cancer have been described in either one or both genes. And I think that is it for the different scenarios and the criteria. So then Kathy is going to take over and present the rest of the slide deck with interesting, with an interesting example and some data that we've collected.
Thank you so much, Karen. That was a great introduction. And we know for the audience listening, it is a lot to think about in terms of having the criteria laid out like that. So we wanted to work through an example and actually pull up the document so you could see how you might apply the different criteria and the evidence that may be gathered. So we'll jump to that, but I'll give you some background about the example fusion that we will be evaluating. So this is a Med14 HOXA9 fusion. This was found in a 41-year-old in whom bone marrow flow cytometry in morphology was felt to be most consistent with the acute lymphocytic leukemia. This was actually a fusion provided to us by one of our work group members that was seen in clinical practice. And so we were able to have the breakpoints as well as the transcript and the associated relationship of those two genes. So I'm going to stop sharing this PowerPoint and we can walk through the document. So this is the sort of working document that Wes Gore developed that allows us to go through and designate on that points-based system which criteria we are applying. So I'll give you some additional background about this gene fusion before we dive in. So one of the things that we tend to think about is wanting to gather a lot of evidence. So as Karen and I can attest to, it does take quite a significant amount of time to be able to rigorously evaluate the data at hand and to try to understand whether a fusion event has been previously reported in the literature. Often information may be restricted to supplemental data files. It can take a lot longer than looking at a small variant, for instance. So just to orient the audience, what these genes do. So Med14 is actually a protein subunit of something called the mediator complex. And so this is a protein scaffold that's very important and critical for regulation of transcription of many, many genes. One of the resources that we often go to is the PCAN database. I know a lot of us like to use Protein Paint to try to better understand whether fusions have been described, if they're captured within this database. Sometimes they are, or where various domains lie that may be important in relation to that protein structure. HOXA9 is actually one of a number of members within a family of homeodomain transcription factors. So these act as master regulators during embryonic development, but in short, they're transcription factors. And they do have a homeobox domain that's been critical to gene function that's been described previously. I did want to point out as well that HOXA9 fusions have been well described within the literature. NUP98 is probably one of the most well described events in the setting of hematologic malignancies involving HOXA9. And this screenshot is from OncoKB, so that's another resource that I know a lot within the community use. They define that as likely oncogenic, but this occurs due to recurrent translocation. And HOXA9 has been well described in relation to overexpression that's been seen in quite a few different leukemic malignancies. And so when we start to think about applying these, what we do is work through the criteria. So we've gained a better understanding initially of what these genes do. And so then we want to better understand Have these been observed together? Have these been documented? And how well documented have these occurred within the literature? And so again, you can see the various permutations here. This is actually something that we're still working through, trying to understand exactly what constitutes the different points values. So you can see in the first one, genes A and B have been previously reported together in multiple peer-reviewed publications. So that's a +2. If those two genes together have been in a case report or a database only, that would be a lower points value at a +1. And then we drop further if either A or B had been previously described in multiple peer-reviewed publications, or if either gene partner had been previously reported in a case report or database only. And so you can see that delineation here. So going back to this particular example, which again was our Med14, HOXA9, there is some literature that's available to be able to look at. So there was actually a nice publication that is a case report, but they do some additional analysis in this where they describe this Med14 HOXA9 rearrangement, and this was in the setting of an adult individual with mixed phenotype leukemia. So they were able to look at the breakpoints by Sanger sequencing, and then were able to report on clinical course and inferior outcome of this individual in the setting of their disease. There were also 2 other large-scale RNA sequencing studies in which this fusion was primarily documented within the supplemental, although this particular paper had a little bit more within the main document, talking a bit about the overexpression that was observed in relation to this fusion event. And this was in a patient with pre-T cell lymphoblastic leukemia. In this particular case, they did not feel like the overexpression met significance because they had another patient with AML who harbored a NUP98 fusion, which HOX98 was very highly expressed in that case. So again, you'll have to take it on a publication by publication basis on how you want to interpret these data. These publications did have some data on the breakpoints and the exons that were involved, which is helpful, including the discrete chromosomal positions. So this, again, is something that may take some time as you're evaluating these fusion events, because you want to make sure that you're indeed working with the right transcript, as long as those authors were able to report on that. And then again, understanding chromosome positions, sometimes even though they're not descriptive, and that's true here, this may still be GRCH37 versus 38, wanting to understand and ensure that you're comparing like to like in these cases. And in this supplemental, they actually did have a nice breakdown. And again, this comes from one of the fusion callers of what that rearrangement looked like and what was retained. So this is sort of native Med14 and HOXA9, and you can see some of the relevant protein domains of interest. This homeobox domain of HOXA9 was retained, and including in that fusion product, which retains the majority of Med14, as well as quite a bit of HOXA9. You can see the homeobox domain is well retained therein. So when we go back to our criteria here, again, this is where you would make a decision on strength of evidence for these. There was some non-consensus achieved within our work group as to how best to document this particular example and whether you consider multiple peer-reviewed publications versus whether this is really a case report, which had the most substantive information about it, and then more supplemental information. Ultimately, since there was extended information in the supplemental about this in one of the publications, I chose to give it the highest points value here, but that's something that we aim to be a bit more discreet about in our actual manuscript when we summarize this, and certainly welcome community feedback. Genes are in the previously described orientation. So from the evidence that I showed you, both were in the previously described orientation. So MED14 was the 5' and HOXA9 was the 3'. And this was true of other HOXA9 fusion events that have been described in leukemogenesis, that those represent the 3' partner. The exons at the junction were consistent with those previously described for both partners. Again, we had at least 3 examples of that. Thinking a little bit more about what is the consequence of this fusion, so whether it's gain or loss, and is that consistent with that previously described for the fusion partners. Here we have the most evidence on HOXA9. There was actually very little about MED14 in and of itself as a fusion outside of this particular gene partner relationship. And so we were able to base this on the HOXA9. So we do know from other fusions that have been described, including the very well-known NUP98 HOXA9, that's a known oncogenic driver, and that's primarily associated with aggressive AML. In that case, this fusion, the NUP98, does indeed retain that HOXA9 domain, and it's thought to act as an aberrant hyperactive transcription factor in that scenario. We did know in our MED14 fusion that the homeobox domain is retained. And then we know in general that HOXA9 is overexpressed in a significant proportion of AMLs, as well as in the supplemental data here, we did see that overexpression that had occurred. This was indeed in frame, and that is consistent with what had been previously reported in the literature, just both for this particular gene fusion example, as well as that previously documented for HOXA9. The observed fusion or one partner has been previously described with the neoplasm under study. And so I'll show you the drop down here. So we have yes and neoplastic restricted, yes and seen in multiple neoplasms, or no or unknown. So we said yes and seen in multiple neoplasms because this has been seen in T-cell leukemia as well as mixed phenotype leukemia. And then for the last 2, this is not a read-through. So these genes are not close to one another. One is on an autosome and the other is on the X chromosome. So this is not a read-through event. And this was deemed NA, this very last scenario. If there's a novel partner, is there similarity in biologic function to that previously described? So in total, this came up to oncogenic at 10 points, again, depending on how you apply this criteria. And Karen and I did want to point out, this is right on the cusp. So if you chose to use a lesser points value there, you're still achieving likely oncogenic. And in general, we know from other classification schema that are out there, as well as this, that for most intents and purposes, likely oncogenic and oncogenic itself are often treated similarly. So I hope that gave you some understanding of the type of work the work group is doing in relation to trying to curate how we would approach these and how you would actually apply those criteria. And then I'll jump back to the PowerPoint and we can talk a bit more about some of our findings to date. Okay, so example fusions were observed by the group from either clinical or research data, and these were gathered to try to evaluate how we're applying these criteria and to have some consistency throughout. So this really allowed us to continue to iterate and refine the criteria over time as we came up against various fusion scenarios that we were working through in relation to the framework. So 2 such examples are here. You can see an ETB6 fusion event as well as an FGFR1 fusion event. So we tried to look across the individuals that were reviewing these on the work group. The ETB6 obtained a consensus VUS here with 8 out of 11 reviewers, and then the FGFR was a consensus likely oncogenic with 8 out of 9 reviewers meeting that. And you can see in some examples of classified fusions, the consensus was not achieved. That was true here within this ETB6 fusion event. This actually allowed the work group to continue to refine criteria, however, to think about points values really to think about applying best approaches to applying various lines of evidence. There was also a lot of education back and forth across the group. I think we have a really diverse work group, which is great because it brings a lot of different insight as we start to evaluate these. You can see in this other fusion example here, this PAX5 ZCCHC7, while we did achieve a consensus, I think that is not quite accurate here, but while we did achieve a consensus with oncogenic or likely oncogenic, we had two individuals that called this out as a VUS. So in thinking about this more, we wanted to dive into this with our work group. So we know PAX5 is actually a major transcription factor that's essential for B cell development. And this fusion event in particular has been fairly well described now in the setting of B acute lymphocytic leukemia. But notably, it's considered a cooperative or secondary abnormality rather than the sole leukemia initiating driver event. And so I wanted to point that out. And I think that's where a number of the work group members, especially those that classified it as VUS, may not have applied certain criteria leading it to maintain a VUS status. So there was certainly some education across our work group that allowed for better understanding and classification of this fusion, particularly for those that may not have as much experience in the setting of hematologic malignancies. And I did want to point out here our definition of fusion oncogenicity, which is a gene fusion, which is contributory to the development, initiation, and or survival advantage in the setting of neoplasia. So early on, as Karen mentioned too in her portion, we tried to evaluate quite a number of different fusion events and are still working through those again in an attempt to iterate and refine the criteria. So from the initial classification schema, we had looked at 4 fusions. These were evaluated by 9 to 11 work group members. We achieved greater than 70% consensus for 3 of 4 of those fusions, which you can see here. In further discussion, actually, on the ETB6, both of these happen to be loss of function events. And so we were able to iterate through that and better understand how best to apply the criteria or to refine the criteria and point to classifications appropriately, given that many of us felt like those are more likely to be likely oncogenic. So we went through, made some changes to the nature of the point system, tried to refine some of the terminology, and with the refined classification scheme, looking at 5 fusions, so the original 4 that were here, plus an additional fusion, you can see that we did achieve consensus across these and did then determine that both of the ETB6 loss of function fusions did meet likely oncogenic classification. I also wanted to point out that additional fusion that we looked at, so that 5th fusion, which was new to the work group, initially came up as a split interpretation, so we did not achieve consensus. However, working through that again and continuing to refine some of the terminology that we were using during that second consensus review, likely oncogenic became the predominant classification. So in terms of our lessons learned, this really came down to familiarity with the tumor disease type under study, which we found influenced some of the application of that classification criteria. So we know in daily practice, whether it's research or clinical, individuals may have a given area of interest or specialty. So that may have a slant in terms of how they're approaching evaluation of a given fusion. But the classification criteria are intended to be broad with the capability of classifying hematologic malignancies, CNS, and solid tumors. So this is really where some careful literature review may need to occur. We found that discussion of consensus reviews amid the monthly work group calls lent greater clarity and best practices for applying criteria. So as we work through this iterative process, we were able to understand where there may be ambiguity in terms of how things were phrased, for instance, or why consensus was not achieved. And so that allowed us to refine over time how those criteria and evidence were laid out. And then upon the first observation of a fusion within a work group, there was a greater likelihood of not achieving a consensus. However, when we reviewed this together, consensus was typically achieved as all of the evidence was presented. And as I pointed out before, it may take some significant time to thoroughly evaluate all of the evidence to allow proper classification of the fusion event. What are some of the challenges that remain? So there are a lack of databases and resources available for fusion attributes. We know this certainly lags behind in comparison to single nucleotide variants and small indels, for instance. Much more manual curation effort because we're trying to look often in supplementary data, really trying to make sure that transcripts and exonic breakpoints and things like that are indeed similar or different from what's been previously described relative to the fusion you're evaluating. So there is that high reliance on primary literature. I did want to point out, and many of this group may have seen this, Cosmic recently sent out a survey this past May, which I took on fusions and trying to better understand what the community would want in terms of desired data types and granularity. So I thought that was of interest and certainly speaks ideally to the availability of more fusion data as well as more granular data in databases coming up. There's also the need to consider assay types from which fusions will be derived and how that may impact the framework. So this is something we're still working through. I think the RNA is fairly straightforward because you're looking at the level of the transcript. Often the assays that are in use, whether they're targeted RNA sequencing based assays or whole transcriptome, again, are based on RNA. But you can certainly think about DNA being called out of genome, for instance, or optical genome mapping. And so we're wanting to better understand and have some fusion examples that show that structural variation leading to an inferred fusion event and how the criteria could still be applied. And then certainly, which is the crux of the purpose of why we're here and why we're developing this framework, is that having fusion oncogenicity defined will aid in curation of evidence and consistency. Ultimately, we feel like this will improve clinical reporting, facilitate data sharing a little bit more discreetly, and help enhance patient care. At that point, I will turn it over to Wes.
Thanks, Kathy and Karen. Obviously, we like community engagement here. So down below are 2 QR codes. We'd be interested in having more of you contribute fusions of interest, both for scenario A and B, especially B if you got them. And then we also wanted to open a call for beta testers to try out our framework and give us feedback. So there's those 2 QR codes. I'll drop these links in the chat too. So if you're interested in doing either of those, you can go and fill out the Google form. And at this point, we wanted to open it up for some open discussion. Kathy and Karen, I know there's been some chat in the chat.
There's been
itself,
quite a bit of chat.
So I don't know if you guys want to go for it.
Point out that in addition to the category 2 fusions that we're looking for examples for, if people have examples of fusions detected at the DNA level, we could also really use those, especially if there's corresponding RNA testing for that as well, so that you can compare what the fusion looks like at the DNA level versus RNA. I also wanted to just emphasize that in some of those examples that Kathy pointed out, the ones where we particularly had a problem with consensus were some of the fusions like with PAX5 and ETV6, where sometimes those can be either like with PAX5 loss of function, or they can be gain of function. And if you're not like intimately familiar with BALL, then if you only pick up on one or the other of those in the literature, you can kind of start going down the wrong pathway with those. So that's where we ran into some difficulties, particularly with consensus in those examples.
That's a great example, Karen, because ETV6 can also be a driver
both
as
of
well
them.
as a tumor
Yeah.
suppressor in that context. So it's doubly confusing.
Yeah. And we should probably emphasize that in the caveats that you have to watch out for those examples. Um, I don't know. Should we go through some of the questions and comments in the chat?
Yeah, I think we should.
So I know the
Also,
first
please
one
feel
that,
free to raise your hand and ask a question as well.
yeah, the first one that I saw was like if in frame is necessary, then shouldn't it receive a higher score? Um, or if it should be in frame and it's not, then should there be more minus points? We had difficulty with the points because we were finding that in general, when we had first ascribed points, that we were getting to likely oncogenic way too quickly. So we started to back off. But yeah, it's a little bit of a tricky balance. Um,
Yeah, and we do account for that. Like, within our criteria, we have it so that if it matches the appropriate expected reading frame based off of like the expected consequence, right? But again, to Karen's point, it's very difficult to come up with a system that doesn't skew you one way or the other, depending on like the point values and working within that framework. And so I think we ended up keeping that as a pretty minimal impact with a plus or minus one for our scenario one. And again, for our scenario two reading frame, stayed a little bit more conservative. I think our group is much more concerned about we don't want to accidentally call something oncogenic that really isn't oncogenic. And so we've taken a little bit more of a conservative approach in trying to come up with these iterations of point values to start.
Yeah, it's tricky to know which way to go because you also don't want to deny someone the possibility of seeing something that could be druggable. One of the things that our group spends a lot of time on individual gene partners is just trying to understand um, where the likely breakpoints are. I mean, so we know where the likely breakpoints are based on the literature, but then when you get outliers, deciding whether those are oncogenic or not is so tricky. Thinking about like, is there an autoinhibitory domain that you're including some of or part of, or what if there's almost all of the kinase domain, but not quite. Like, where is the cutoff for that? And those are the kinds of edge cases that we really struggle with because which partners are there is pretty well, like for a lot, at least a single partner in most cases is really well documented, as you mentioned, because of the types of screening that most groups are doing in terms of target capture and that sort of thing. But the breakpoints are very, very tricky.
and we do have some examples of what you're talking about where it's like a very non-canonical breakpoint in a fusion that if you're just looking at the genes, you're like, oh, well, this has to be it. But I think those often come out as VUSs.
Yeah, I mean it's just impossible. I mean VUS in the sense that we just don't know.
Right. Unless you
But
have
they
functional
could be
data, which you
oncogenic. We
never
don't know.
do, right?
Yeah. Yeah, it's very hard to know what to do with those. Yeah.
This is Beth. So I guess that's just a plug for reporting your VUSs too. Even if you don't
For
know,
sure.
and if they have something that's druggable and they have nothing else to lean on, then I mean, maybe there's an opportunity. But yeah, kinda-
Also, do you report? I'm working on a case right now like this where it's there's an alveolar rhabdomyosarcoma. It's got a PAX FOXO1 fusion, but there's this also this other fusion there with really high read support that
mhm.
I mean, it's a little bit confusing in the literature because it has been reported as both an artifact when there's low read support, but it's also been reported as a real fusion in different sarcomas. This one doesn't look like artifact because it's extremely high read support, even like higher read support than the FOXO1 fusion. So do you report those? Do you just report them as a VUS?
It depends on in my experience, it depends on the genes and like, what's the mechanism? Is the mechanism known? Are the genes well known enough that you could like propose a mechanism, or are they well enough associated with the diagnosis to call it likely oncogenic in any context? And if so, then we'd probably mark it as likely oncogenic. But I think that we, like, our institution has fairly strict standards on that. Like, we don't just, we don't even mark like tumor suppressor disruptions as likely oncogenic unless there are like examples in the literature of fusions being a mechanism of loss of function. So like we're creating our own data sets, I feel, all the time with that.
Yeah, and there's a lot of controversy around that too, because there are other groups that would want to, like, anytime there's any kind of disruption of a tumor suppressor, whether it be by fusion or mutation or deletion, would want to report that. So it's tricky.
I feel like we
Right.
could use a whole other effort that supports best practices in reporting, just because there's been such, I feel like, historic ascertainment bias as to what's been put out there, and each different institutions tends to have their own decision making on what gets into those clinical reports.
Mhm. That's really why this work is so needed, is because there really isn't any guidance on it. So people are relying really heavily on the literature and what we know, and then trying to make their best judgment. But like as we see, like institution to institution, that can be just really different. So thanks for all you do.
Oh, and thanks for all the input. And, to add another plug for the Section 2 scenario, which we've struggled with, I think one of the other challenges has been because we're considering as part of that very first criteria for scenario one, whether either gene has been previously reported, either in the peer-reviewed literature, a case report, or a database. You can almost always find some evidence of a gene in some database somewhere being described, but whether there's, any additional data to gather anything of meaning from that has made it very challenging. A lot of the whole transcriptome studies have been published at large scale for some of the, looking at across different cancer types. And so you can come across these, but they're often without meaning and you don't have a lot else to go on.
Again, we're very interested in beta testers. So if that is something that you are interested in doing, please let us know.
I'll say I'll be signing up.
We'd love to have you.
Okay. Are there any further questions for Karen and Kathy?
Just a quick one. Hi, I'm very, very happy to see, the progress being so mature. I wanted to ask whether there could be a guideline for combined RNA and DNA. You mentioned this, but with RNA transplicing sometimes is very confusing and it's very difficult to identify whether this is a subclonal event that you're witnessing or this is a transplicing event just because the machinery, is kind of crazy. And most of at least for our findings, come from RNA, like everybody else's, and there could be potentially an asterisk, for that would be good to have additional evidence on the DNA side, just because it's impossible to distinguish between the two for low clonality events.
Yeah, we ran into that frequently in the BALLs with the P2R08 CRLF2 fusions. I think that has been a point of confusion for a lot of labs because they pop up, but they can be either drivers or subclonal. And we ended up, just because our lab does so much children's oncology group work, we were able to come up with a cutoff based on the level of, if we didn't have other evidence, based on like fish or, um, that of the percentage of cells involved, we ended up coming with a cutoff based on read support that was based on correlation with the low density array that was also being done at the same time with the expression analysis. But it's really tricky if you don't have all of that information.
Yeah, it's hard, and I think, I'm not suggesting a solution. I mean, the solution is to have everything. If you have everything, then it's always great. And whole genome sequencing, potentially it's even better. And for your RNA long read, so it's, if you have everything, it's easy. But raising it, especially for a guideline, publication, raising it as a tricky, situation that needs attention and potential mitigation measures, as you mentioned, thresholding. Again, thresholding doesn't save you for low clonality events. So you will have the same number of support, even if it's real or not. So yeah, I think just an asterisk there, to raise the attention, hoping as these technologies become more and more widespread, it will just become easier by itself.
Thank you for all this work.
Any further questions for our presenters? Okay, hearing none, I will thank them again for sharing the work of the Gene Fusion Oncogenicity Group with all of us, and reiterate their call for contributions towards testing the framework as it develops. We'll send around an email after this meeting with links where you can go and sign up to participate in that effort. Thanks once again to everyone, and we'll see you next time.